My name is Sophie Storva. I'm in the 10th grade and this is my electrical house project. First thing, what are series and parallel circuits? Well, series circuits have only one path for current to flow. The current is the same through all of the elements, and if one element stops working, for example if a light burns out, then the entire circuit fails. A parallel circuit is a very wonderful thing because if an element dies, all the other branches are not affected because the branches have the same amount of current. They don't depend on each other. There's multiple paths for the current to flow. So, possible elements that can be in a circuit. We have a master switch, we can have a motor, different types of switches, a dimmer, regular light bulbs, all those types of things. We can have a buzzer, a circuit breaker. Those are just some of the few. So the first floor of my house, which is here, this is the diagram for it. So it's a parallel circuit consisting of 4 branches. There is 4 different switches. There's a master switch and 1 battery is controlling all of it. And of course there's a dimmer included in floor plan number 1. Difference of color, so this is the first circuit and this is the second one, and they're connected on half of the floor. Floor 2, so they're broken down in halves, which is this part of the house. So this is the diagram. This is for the first room, has 4 lights, 2 switches, pretty simple. And then the second one, it has a motor, another one of the requirements for this project. Also connected to 1 battery. The next side of the house, which is this side, is connected in a series circuit. Again, one of the most simple circuits. If one of the light bulbs burns out or the switch glitches, the entire thing falls apart. So let's talk about the master switch. You can pause it though. Okay, so this is a house. I will connect the batteries to it and I will demonstrate how each light works, how every circuit works. So 3 batteries connecting different parts of the house so it's not too dim. Alright, so there's 3 master switches for battery. So we are going to start with number 1. Here is the first floor. We have these lights here. They're controlled by 1 switch. Then we come to the middle. This is our living room. Here's a switch to control these. This is connected to this. Then we come into the kitchen back there. If you can see, can you see it? Switches, turns on, turns off, and one of the requirements, the dimmer, it never comes off, so it's like the emergency light in the house. And then the master switch, it all turns off. Perfect. So that's floor number 1. Now, we're going to come to the first side of the second floor. Master switch is back here. 1, 2, 3, turn it on. All of it's turned on. And the fan's back there. We have a switch to control these 2 lights. Here we go. Light number 1. Both of the lights. We turn this off. We have a switch here. And then our motor, light, and we have a switch to control that. Turns off, perfect. And then there's a master switch. Let me turn everything back on. 1, 2, 3, off. That is the second part. And then we're going to come over to the last part of the house, controlled by a separate battery. Again, parallel. It's a series. So back there, we have those 2 lights for the bathroom and one of the rooms. We have a switch to control both of them. the series circuit. And then we have another series circuit. We have these two lights and are also turned on and off by one switch. And then we have the master switch. Let me turn these two off. 1, 2, 3, and off. So those are the 3 batteries and the 3 master switches. So back to the TV, our voltage and current. So these numbers, this is for the first battery, for the first floor. The voltages are all different and they should add up to have 8.94 volts because the voltage is distributed through each of the elements. Amperes is the current and are more or less alike through each of the elements. It just depends on which battery I use because I use different ones at different times. Floor 2, this is the first part. Again, we have our volts and then we have our amperes because these light bulbs are connected in different places. So technically they're supposed to add up to 6.93 amperes. It's the amount of current that is flowing through each of the elements when all of them are turned off. Again, they vary based on which battery I use because some had more than 9 volts, some had less, depending on its usage. And then the last part, this is our series circuit, which is part 3 of the house. They add up to 7.52 because in a series circuit, the voltage is split evenly in all of the between all of the elements, and the current in each one is completely the same. So in the end, some challenges that I faced was figuring out how to place the wires inside of the house and how to organize them, so to make sure I can recognize them to measure the voltage and the amperes later. And I had to make sure I had enough current to make all of the light bulbs and the motor light up. A problem was making the motor work when I had other elements connected to it because the motor needs a lot of energy. Some positives. So the fact that I understood how to create a parallel and a series circuit really helped me with making them and placing them inside the house. Connecting them, I really had no trouble connecting the wires so they wouldn't work. So that was great. Yeah, that was a fairly simple thing, creating flow of energy. That was great because I understood the theory. So this is my house project. Thank you very much. Da, 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 da.